Hey everybody, this is Mr. Keeney again, back with another geometry remote learning lesson. Today we're going to focus on trapezoids, specifically the area. So here I got a picture of a trapezoid labeled with the parts that we would need. Got these parallel opposite sides here. That tells us they will be the bases. And I've got my height labeled right here as well. Same thing as triangles, parallelograms, it will be perpendicular to both of our bases. These are called the legs. Don't need them as much for area. We would if we were going to do perimeter. Area formula, area of a trapezoid. Area equals 1/2 times base 1 plus base 2 times the height. Just kind of like how I did in the last lesson about why did a rhombus and a kite have that area formula. I like to do that for trapezoid as well. So you're going to have to use your mind's eye with me here real quick. But here is a trapezoid, actually just a copy from the one above. And if you would, imagine that I take a copy of this and I'm going to flip it upside down, so I'm going to reflect it, and then I'm going to translate it over. And so this is what I want you to think of, and my drawing may not be perfect, but I'm going to do my best. This is a copy of this. I just flipped it over, moved it across, and if you would imagine for me, here's that height. The right angle would end up right here. I'll put it this way though. This would be base 2, and base 1 would end up down here. Now, what have I made here? I have made for this whole entire shape, so the whole thing, both of them put together, is a parallelogram. And if I were to find the area of a parallelogram, that would be base times height. But more specifically, let's talk about this base right here. The base is here, just like the base would be up there. So let's talk about what is the base, not just B, but it's base 1 of the trapezoid plus base 2, base 1 plus base 2. So if I want to find the area of the entire parallelogram, the base would be base 1 plus base 2 times the height, B1 plus B2 times the height. So where does this 1/2 come into play? And I'll remind you that we only want this one right here. That was the original trapezoid we wanted the area of, so I'm going to have to take away this that I'm shading in. How would I take that away? Well, if I doubled this, if I made a copy, I'm taking away half the area. So that is how we get 1/2 times base 1 plus base 2 times the height. Just if you ever wondered, where the heck does this come from? That's where it comes from. It came from a parallelogram and splitting it into 2 trapezoids, or starting with the trapezoid, copying it, making a parallelogram. Either way, we're going to use this to do 2 example problems real quick. And then there is some that are given to you to try on your own. So find the area of the following. We are working with the trapezoid, so area equals 1/2 times base 1 plus base 2 times the height. Area equals, and I'm just going to go straight into plugging in what I know because I think they give me everything. 3 and 7 are my bases. I know this because my height right here would be perpendicular to both. So 3 plus 7 is going on the inside, and my height is 4. So area equals, I'm going to do 1/2 times 4 to get 2. So 2, and then 3 plus 7, and here is 10. So my final answer would be 20 units squared, or square units. So that is the area. Not asking you for a perimeter today, just area. To do one more, the only tricky part about this one is when we get to one of the bases. Other than that, it is pretty straightforward again. Plus right there. This base, if I were to add this little segment addition postulate, part plus part equals whole, 6 plus 18 is 24. So one of my bases is 24, the other one is 6. And we actually do not have a straightforward problem because I got a problem here, the height. This 10 goes with this leg. So if you were to see this right triangle for me, this one over here, I've got 2 sides, I got 6, I got 10, and I have to find the missing leg. So that is going to scream, or I hope it screams to you, Pythagorean theorem. So I set this up here, h squared, which is a leg squared, plus 6 squared, a leg squared, equals 10 squared. For those of you that know your Pythagorean triples, you probably know what this is already. If not, I'm going to work it out. H squared plus 36 equals 100. Take away 36 from both sides to get h squared equals 64. Square root both sides, h equals 8. A reminder that we are only taking the positive root because the negative root would not make sense in this context. In geometry, we have positive distances, never negative. So our height ends up being 8. Just after that little detour, we are ready to simplify and get our final answer. Half of 8 is 4. And just again to show you, half times 8 would give us 4. And then 24 plus 6 is 30. Multiply these together to get 120 square units. So that is it for the practice problems today. I did give you guys some to try on your own if you would like. We will see you again tomorrow for more of geometry remote learning. Thank you.